Good morning to all of you. A warm welcome in this lecture on injection molding. As you are well aware that we are in the process of discussing the processing of plastics. Whatever we have discussed till now, let us just have a brief overview or review of what we have finally discussed. We have discussed the basic difference between the thermosets and thermoplastics or the types of plastics in the very first lecture. In lecture number 2, our focus primarily was on the mechanical properties, in which we have seen some of the important mechanical properties in context of the plastics. If you remember, in lecture number 2, we have seen the stress strain behavior, that how the thermoplastics would fail if they are loaded in the tensile direction. We have also seen in lecture number 2 that what is the casting process specifically in context of the plastics, because casting is a very general process which is used in metals, but in plastics also we can do the casting process. We have seen what are the application areas of casting specifically for plastics, and also we have tried to understand that what are the advantages and limitations of the casting process, because as the title of our module is processing of plastics. So, our focus primarily was just to have an overview of what the plastics basically are, what are the important characteristics of the plastics, and finally we shifted our attention towards discussing the processing aspects of the plastics. So, in the lecture number 2 we have discussed one of the important processes, that is casting. In lecture number 3 our focus was on the extrusion of plastics, in which we have seen that what are the various process variants in extrusion, what are the different types of or we can say in other words what are the different types of extrusion processes depending upon the requirements which are done on plastics, and what are the different types of products which can be made by the extrusion process. Then in lecture number 4 we have discussed what do we mean by transfer molding. In transfer molding we have seen that what is the basic process, we have tried to understand it with the help of a diagram. Also we have seen that what is the compression molding process. In compression molding also we have drawn a very simple diagram and tried to understand that how compression molding of plastics is done and what are the important process variables in compression molding process. So, this is just an overview of what we have already discussed in this particular module, that is processing of plastics. Why I emphasize the revision of what has already been discussed, because if somebody is interested in some other topic, then he can get an idea that this particular topic is available in this particular lecture. So, we have already discussed few processes. Again I would name the processes like casting of plastics, we have discussed extrusion of plastics, we have discussed transfer molding in context of plastics, and we have also covered the compression molding of plastics. So, today our attention is the injection molding of plastics. So, there are large number of videos which are available on the internet which give us an idea about the injection molding process, but as a learner we should try to understand that how actually the injection molding process takes place and what are the important process variables that have to be taken into account when we are trying to understand the basic principle of the injection molding process. So, it is a very widely used process. The machines are commercially available, that is injection molding machines are commercially available, and a wide variety of products are made by the injection molding process, and we see a large number of applications of injection molding process in our daily life also. But most of the engineers do not get an opportunity to study the processing of plastics in their regular curriculum. So, this particular course, that is processing of non-metals, has been designed so that whatever materials are not covered in most of the curriculum can be covered here in this particular course. For example, we have already seen that what are ceramics, we have seen what are glasses, and subsequently we would be focusing on some other important materials like polymer matrix composites and ceramic matrix composites, which are not usually covered as a subject material in most of the syllabi. So, today our focus is on injection molding, and injection molding, I am emphasizing again, can be used for polymer matrix composites also. So, in our module on processing of polymer matrix composite. Again we would be discussing injection molding, but with an important point that how the reinforcement can be added. But today our focus would be to primarily discuss the basic principle of injection molding, in which the raw material is a plastic. So we have a raw material which is a plastic, and we are converting this raw material into the final product. So the final product that we will get out of the injection molding process would be a plastic product. It would not be a polymer matrix composite or a fiber reinforced plastic product, because that particular product we will discuss specifically when we will be discussing our next module, that is processing of polymer matrix composites. So today our focus is the processing of plastics, and the process that we are focusing on is injection molding. So with this introduction, now let us start our discussion on the injection molding process. Injection molding. Injection molding is one of the most commonly used processing method for plastic components. It is a fully automatic process, and the raw material is converted into the final product. The shape and size of the final product depends upon the mold or the die which is used in case of the injection molding process. So it is a automatic process, it is a commercialized process, and it is a very fast process. The production rate is also very high. So again I am emphasizing on point number 1, that is injection molding is one of the most commonly means it is widely used, and this is one of the important processing methods for processing of plastic components. Point number 2 on your screen. It is used to process thin walled plastic parts for a wide variety of shapes and sizes. This point I have already emphasized, that we can make a wide variety of components using the injection molding process. So the size can be variant, means we can have different sizes, we can have different shapes. For example, the syringes, surgical syringes can be made by the injection molding process. Even the plastic buckets or mugs can be made by the injection molding process. So the application spectrum of injection molding is very wide. So we can have different shapes, different sizes products made by the injection molding process. Point 3 on your screen. Plastic material is melted in the heating chamber and then injected into the mold, where it cools and finally finished plastic part is ejected. So why this point has been emphasized here? Because if you remember in the process, in our lecture on processing of plastics or the basic fundamentals of processing of plastics, I have emphasized 3 important points or 3 important alphabets, that was H, F and C. H means heating, F means forming and C means cooling. So H, F and C are 3 fundamental words which are used or which are important when we talk about the processing of plastics. So here also the 3 words are coming into picture. Again I am reading the sentence on your screen, you can have read again. Plastic material is melted in the heating chamber. So first word is coming into picture, that is heating. So the plastic material is melted in the heating chamber and then injected into the mold, that is forming, because the final product would conform to or would adhere to the shape of the mold. So we are now changing the shape of the molten plastic into the desired shape, and the desired shape is the shape of the mold, or the desired shape of the final product is the shape of the mold. So first is we are heating it, that is the alphabet H, then we are forming it, that is in the mold, and finally it is allowed to cool. The 2 mold halves would remain in contact until the plastic has solidified into the final product. So the final stage is the cooling stage, and once the final product has been formed inside the mold cavity and it has cooled down to the respective temperature, the 2 mold halves open and the final product is ejected out of the mold cavity. So again the three alphabets are coming into picture, that is the heating of the plastic, the forming or changing the shape of the plastic, and finally the cooling of the plastic, and the last stage is the ejection of the finished product out of the mold cavity, which is achieved by the ejector pins. So I will first draw a very simple diagram and we will see that how the injection molding process actually takes place, and finally we will revise this diagram with a complete diagram on your screen, and then we will see that what are the important units of the injection molding machine or the injection molding process, and we will try to see that what are the important points to be taken care of when the injection molding process is taking place, and finally our focus would be to understand that what are the advantages and what are the limitations of the injection molding process, and finally we will see some of the products which were made by the injection molding process. Now this is the outline of the today's lecture. So let us start by understanding the injection molding process with the help of a simple diagram. So on your screen you can see I am going to draw a very simple diagram of the injection molding process. This is the hopper through which the raw material is going to come. This is hopper, and the raw material is available in the form of powder or it can be available in the form of pellets. So we can have a raw material, the raw material can be in the form of pellets or it can be in the form of powder. So this is the hopper in which the raw material is kept. Then we have on your screen you can see I have drawn a cylinder. This is a cylinder. So we have a cylinder and a hopper. So the raw material is there in the hopper. We can say this is our raw material. So the raw material is coming from the hopper and it is entering the cylinder. And here we have a piston. We can call this is a piston. Now this piston will have a movement in this direction. So the piston will be used to push this material, whatever is coming from the hopper, into the cylinder towards the mold. Now where is the mold? The mold is placed at the end of the cylinder. Now this is the mold. It is made in two halves. I am drawing the two halves of the mold, and this is the mold cavity, or we can say the final shape that we want to create. Now this is the final shape. Again we can say this is our molded part, or the final product we can say that we want to produce. It is a plastic product that we want to produce. So this is our mold. The mold is made up in two halves and we have On your screen you can see we have two ejector pins. Now these are called the ejector pins. What is the role of the ejector pins, that we will see in the subsequent slide, but important point is that the mold design is also very important. So let me first complete the diagram, and then finally we will see that how actually the process takes place. So till now we have seen that we have a hopper in which the raw material or the plastic raw material is kept. The raw material is in the form of the powder or the pellets, and then this raw material from this hopper it enters into the cylinder, and in cylinder we have piston and cylinder type of arrangement in which the raw material that is entering into the cylinder is pushed towards the mold. The mold is at one end of the cylinder, and then we have the ejector pins which are used to eject the final product out. But this is not the total process as a whole, because if you remember the three important words that we have discussed before, what are those three important words? First one is heating. So there is no heating taking place in this process till now. So we have to have arrangement for the heating elements also. Second is forming. The forming is going to take place inside the mold. And finally the cooling. The cooling is going to take place inside the mold. The two mold halves would be closed, and finally the ejection. So the ejection would be done with the help of the ejector pins that I have drawn. So where would the heating elements be? Let us now draw the heating elements. So on your screen you can see we can have different heating elements around the cylinder. Now these are the heating elements, or we can say all these are the heaters, and on the bottom side also we have the heaters. So this is going to heat the material, and here we have, this is the, we can say, is the heated plastic which is going to come and enter into the cavity which is generated between the mold, and we have the ejector pin. So heating is there, forming is there, and finally the cooling is taking place. Now the diagram as a whole is complete. Now this is also called the, this particular section is also called the injection chamber. So we have a injection chamber, we have a piston, we have a cylinder, and heating elements, we have a mold, and we have a, we can say, ejector pins which are used for ejection, and a hopper from where the raw material is going to enter, and the raw material would be available in the form of powder or pellet. So let us now see how actually the process is going to take place. So initially we have a hopper. On your screen you can see we have a hopper in which we have the raw material. So we have a hopper in which the raw material is kept. The raw material can be in the form of the powders or the pellet. From here the raw material will enter into the cylinder, and in cylinder we have the piston and the injection chamber type of arrangement. The piston would be pushing this raw material to in the cylinder, and there is a heating arrangement which would be used to melt the raw material, which is the plastic material. Once it has melted, it will be pushed through the sprue. This can be called as, this particular section on your screen can be called as a sprue. Through the sprue, the material would be entering into the mold cavity. The mold cavity is being generated between the two halves of the mold. One half of the mold would be in contact with the cylinder, and the other half of the mold would be movable. So the cavity which is generated between the two halves of the mold would be filled by the molten plastic under pressure by the piston, and the two halves of the mold would remain closed until the plastic has solidified and it has taken the shape of the mold cavity. After the solidification or the cooling process has taken place, once the product has cooled, the movable half of the mold would move back, and most probably in most of the cases the product which has formed will move away with the movable half of the mold, and finally the ejector pins which are hydraulically operated will push the product away from the movable half of the mold, and the product or the plastic product would be collected. So, this is a simple representation of the injection molding process, and we will try to understand this with the help of the diagram again. Now, let us see the diagram on your screen, the complete and a very clear diagram which is available on the screen. You can see again this is the similar type of diagram. Let us now again try to see how the actual process is taking place. Now, we have a hopper. In this hopper we have the raw material which is available in the form of the powder or the pellets. We have a piston which can move in this direction. It will push the molten plastic into the mold half. The mold is made up of two halves, one is fixed, another half of the mold is movable, and then once the raw material enters into the cylinder, it will be pushed by the piston. There are the heating elements. The heating elements will melt these pellets, and the molten pellets or the molten plastic would be pushed into the mold. Here this is the final product that we want to make. This is the cavity which is generated between the two halves of the mold, and finally this particular plastic would be allowed to cool. After cooling, the movable half of the mold, this half, would move back, and this will travel along with the movable half, and finally the ejector pins will operate, and this will push the half or this particular product out or away from the movable half of the mold. Now, this is the total injection molding process. So, basically we will again try to revise what we have seen in this particular diagram. Basically there are 3 or 4 important steps that are taking place. If you remember, there are closing of the mold, that is creating of the cavity or the mold cavity which is in conformance to the final product that we want to generate, that is clamping of the mold where the cavity is being formed. Raw material is fed into the cylinder, it is pushed by the piston, the raw material is heated and melted by the heaters, and finally under pressure it enters into the mold cavity. It tries to fill each and every corner of the mold cavity, and where it is allowed to solidify or it is allowed to cool, and once it cools, the two halves of the mold open, the movable half of the mold moves back, the final product also is attached to the movable half of the mold, and finally the ejector pins are actuated hydraulically or pneumatically, and this will push the final product out of the mold cavity. This is one cycle. Again the two halves of the mold would close down, forming a cavity conforming to the final shape of the product. Again the raw material would enter from the hopper into the cylinder, the piston would push this material, the material would get heated inside the cylinder because of the heating elements, and under pressure it would be injected into the mold cavity where it would be allowed to cool and take the shape of the mold cavity and that of the final product. Now, this is a simple single cycle of injection molding. So, number of cycles per hour or number of cycles even sometimes per minute can be done. So, this is a very commercial or very widespread used process, and it has got lot of applications also, and the production rates are also very high. Now, let us try to understand the various stages of the injection molding process. Now, although I understand that most of you have got an idea that how the process actually takes place, I have drawn a diagram. We have also seen the complete diagram 2-3 times. We have revised that how the actual process is taking place. Now, let us just read the various stages of the process. Plastic materials usually in the form of powder or pellets are fed from the hopper into the injection chamber. So, That is the first point. From the hopper, the raw material is being fed into the injection chamber. The piston and cylinder arrangement is used to forward the material inserted from the hopper into the injection chamber. So this piston is used to push this material towards the injection chamber. Secondly, the material is heated in the injection chamber with the application of heating element. So again we have to melt the raw material in order to push it into the mold cavity finally. So first thing is, the raw material is coming from the hopper. It is being pushed by the piston towards the injection chamber. In the injection chamber there is a heating arrangement. So heating is going to melt the raw material into the molten stage. The molten plastic material is then injected into the mold through the nozzle. So there is a nozzle towards the end of the injection chamber through which the molten plastic would be injected into the mold cavity. The plastic part is cooled quickly in the mold. Sometimes we may have a cooling arrangement in the mold itself so that the cooling process is accelerated. So the plastic part is cooled quickly in the mold. The finally plastic part is removed from the mold. After the cooling process has taken place, the final product would be removed from the mold. The process cycle for injection molding is very short, typically 2 to 60 seconds. So one cycle can be completed from 2 to 62 seconds is very fast, but on an average maybe 30 to 35 seconds one particular product can be made using the injection molding process. Now the complete injection molding process can be divided into 4 stages. Now as we have already tried to understand, and now let us break the total cycle into its constituent or independent stages. First stage is the clamping. The clamping means that the two halves of the mold which are in the beginning separate will close down or would be clamped. Why they would be clamped? Because the cavity is generated or cut inside the two mold halves. So one mold half is fixed, another mold half is movable. The movable half would travel towards the fixed half and the two mold halves would be clamped together, forming a cavity inside. So the first stage is the clamping or the formation of the mold cavity. So first stage is clamping. Second stage is injection. In injection there are 2-3 small steps, that is the raw material would be entering from the hopper into the cylinder, from where with the help of a piston it will be pushed into the injection chamber, and injection chamber it would be heated by the heating elements, and finally with the piston and cylinder type of arrangement it would be pushed towards the through the nozzle into the mold cavity. So all these micro steps or small steps are totally covered in the injection step. So first is closing down of the mold or clamping of the mold, two mold halves, and then the injection. In injection there are these 3-4 steps that we have already covered. Again I will revise. The raw material in the form of powder or pellets would be coming from the hopper. It would be coming into the cylinder. In the cylinder, piston would be pushing this raw material towards the injection chamber. In injection chamber we have the heating arrangement, and this heating arrangement would melt the raw material, and finally using the piston and cylinder arrangement it would be pushed through the nozzle into the mold cavity. That is the total injection step. And finally once the mold cavity has been filled by the plastic which has been injected into the mold cavity, it would be allowed to cool for a specific period of time depending upon the total injection cycle, total injection molding cycle. So the cooling will take its own time, and once the cooling has taken place, the product has been formed. It means the two mold halves would open. The final product would be attached to the movable half of the mold. The movable half of the mold would move back, and finally the ejection of the product would take place. There would be ejector pins present in the movable half of the mold, and these pins would be actuated, and these would give a gentle tap or a gentle push to the product which is attached to the movable half of the mold, and finally this product would be collected as a finished product. And as it has already been emphasized that it is a completely automatic process. Most of the injection molding machines that are available today are fully automatic. So all these steps would be timed. For each and every step a fixed time would be fixed, and depending upon that time we can calculate that what is the production rate, that in one particular hour or 1 minute how many products can be made, or in one day or one particular shift how many products can be made. So the 4 important steps or 4 important, we can say, stages are closing of the die, injection of the plastic into the mold cavity, cooling of the final product inside the mold cavity, and finally the ejection of the final product from the mold cavity. So these are the 4 important stages in the injection molding process. Now let us see some important features of each stage. First stage is clamping. 2 halves of the mold must be tightly closed before the molten plastic material is injected into the mold. So this is giving us the meaning of clamping, which I have already explained. 1 half of the mold is attached to the injection unit, that is the nozzle that we have seen in the diagram, and the other half is allowed to slide on the guideways. So which I have already explained that the mold is made up of 2 halves. 1 half is attached to the injection unit through the nozzle and the other half is movable. So the clamping has to be done between the 2 halves of the mold. The clamping of mold is operated hydraulically, so which means that it pushes the moving half of the mold towards the fixed part to make an airtight chamber, or this chamber we can call as the mold cavity. So the clamping unit is operated hydraulically. So 1 half is fixed, another half would be made to move and it will get clamped with the fixed half. In between we will have the mold cavity. The pressure and the time required to close and open the mold depends upon the machine capability. Now we can have machines with different clamping forces and the time required to close, because this will finally dictate the production rate. If it take lots of time to close the 2 mold halves, the production rate would be less, but if this process of clamping and opening is quick, the production rate would be very high. So depending upon how much time is taken, how much force is required, we can have different types of machines. Again, to revise, if the clamping is quick, the production rate would be high. If the clamping and declamping, we can say, is very slow, the production rate would be very low, or it would be a slower production rate machine. First stage is clamping, second stage is injection. The plastic material is melted by the application of heat and forwarded through by the piston towards the nozzle and finally into the mold. So in injection, as I have already told, the raw material in the form of powder or pellets is fed from the hopper and it is then melted by the application of heat. We have seen in the diagram there are heating elements, and finally it is pushed through the nozzle into the mold cavity. The molten plastic is then injected into the mold quickly. So we do not want to have a thermal gradient or thermal stresses in our final product. So the filling process of the mold should not be very slow. There should be optimal rate of filling of the mold cavity. It should not be too slow and it should not be too fast also. The amount of material that is injected into the mold is referred to as the shot volume. So this is another term that is coming into picture, that is shot volume. So the amount of material that is injected into the mold, that is one shot. If one piston, in one stroke of the piston, how much material is entering into the mold cavity, so that may be termed as the shot volume. So the amount of material that is injected into the mold is referred to as the shot volume. The injection time can be estimated by the shot volume, injection power and pressure. So we can see that how much time would be required, or the how much injection time would be required, and it will depend upon the shot volume, the injection power and the pressure. So all these are important points when we are going to optimize our injection molding process for a specific plastic material and for a specific product. There are other parameters also which has to be taken into account: the complexity of the final product, the size of the final product, the characteristics, physical and chemical properties of the plastic that we are processing. There would be a large variety of criteria which has to be taken into account while we are going to optimize the injection molding process for a specific product. So these particular points highlight only, we can say, some of the important aspects which have to be taken into account when we are indicating or when we are advocating the use of the injection molding process for a particular product. Now, what are the various types of materials used? This gives a long summary of materials that can be used, but just I will read few of the important materials which can be used. So, the injection molding process can be used to process materials such as acrylonitrile, butadiene, styrene, ABS, which is written on your screen. Nylon, it can be used for polyether ether ketone, it could be used for polyphenylene sulfide, or it can be used for polyvinyl chloride. So, different types of plastics can be processed by the injection molding process. Now, let us come to the advantages and disadvantages of the process or the limitations of the injection molding process. Now, what are the advantages? On your screen you can see it has already been highlighted that the injection molding process can be used for a very high production rate. If you see, the cycle times are very short and a large number of products can be made in a day or in a hourly basis. So, the production rate of injection molding is far high as compared to the other processes that we have seen in the processing of plastics. Another important advantage is that close tolerances on small intricate parts can be achieved. So, what does this mean? That there are two important points in this particular highlight, that is close tolerances can be achieved, that is one important point, and second is small intricate parts can also be processed. Why? Because we are injecting the raw material, that is a plastic in this particular case, at high pressure. So, the name also injection molding. So, we are injecting the raw material into the mold cavity at high pressure. So, it means that the raw material can be supplied to fairly intricate parts of the product design. So, injection molding can be used for fairly intricate products as compared to the other processes. So, the minimum wastage of material is there because the metered amount of material is entering and finally we are pushing the required material into the mold cavity. Yes, there would be some material left in the sprue which has later to be cut off, but still the amount of wastage of raw material is minimum in case of the injection molding machine. Complex geometry can easily be produced, which I have already highlighted in point number 2, that intricate parts or intricate product designs can be achieved with the help of injection molding process. So, once again I am going to read what are the important advantages of the injection molding process. On your screen you can see high production rates can be achieved, close tolerances with intricate parts, and minimum wastage of material, and complex geometry can be easily processed. But still there are few disadvantages, that is tooling cost is higher, the amount of mold or the die which is used for injection molding machine is very high, because it has to have certain specific arrangements. As one of the arrangements we have seen, that is the ejector pins which are operated mechanically. So, we have the cost of the tool which is high, that is one of the limitation. The total setup cost is also higher as compared to the other processing techniques for plastics, that is another disadvantage which is related to injection molding, because we need to have a complete injection molding unit where we need to have a temperature control, we need to have a pressure control, and there can be other important aspects which are also important, which or other control variables which have to be controlled for the effective and efficient utilization of the injection molding machine. So, there are a large amount of control parameters or control variables which have to be controlled, and therefore, the cost of the injection molding unit is, we can say, higher as compared to the other processing techniques which are used for processing of plastics, and the large undercuts cannot be formed. Yes, there are few limitations in terms of the product design or the geometrical features of the product design, like one of the limitation is shown on the screen, that is that large undercuts cannot be made with the help of injection molding machine. So, although the process is widely used, it can be used for a large variety of materials, it has got, we can say, a number of advantages, but certainly there are few gray areas where still efforts are required in order to further improve the application spectrum of the injection molding process. Now coming on to the application areas, that what are the important applications of injection molding. The injection molding process can be used to manufacture thin walled plastics, such as, you can say, which require many ribs and bosses on the interior surfaces. Now suppose we want to have a drilling gun, hand drill, in which we want to have a casing or plastic casing. Inside the we can say body of the gun, there would be so many ribs and so many additional attachments. So it is a complicated product or plastic, we can say, housing of a hand drill, which can be made by a injection molding process. So the injection molding process can be used to manufacture thin walled, where the cross sectional thickness or the thickness is less, thin walled housing products which require many ribs and bosses on the interior surfaces. One example I have given, the housing which can be a plastic housing which can be used for housing the hand drill. Second important application is, these housings are used in a variety of products including household appliances, electronics, power tools, and as automotive dashboards. This I have already explained. The hand drill can be one of the power tools which is used, and which is used for which uses the housing, plastic housing, which can be made by the injection molding process. So injection molding, as in these 2 points we can just summarize this, that it can be used for thin walled sections, or it can be used for thin walled plastic housing products. So as we have seen, injection molding can be used for thin walled products, include different types of open containers such as buckets. So in today's lecture, only in the very beginning I have taken this example that buckets can be made, mugs can be made by the injection molding process. There can be other examples where thin sections of plastics can be made, and this is the most suitable process for processing those plastic parts. And finally on your screen you can see, it is also used to produce several daily use items such as toothbrush handles or small plastic toys, many medical devices including valves and syringes, which I have already indicated in the very beginning of today's lecture, that syringes can be made by injection molding process. So these particular examples are just an overview of the application spectrum of the injection molding process. There are large variety of products which are made by injection molding and which we see all around us in our day-to-day use. We see a large variety of plastic products around us, and many of them are processed by the injection molding process. So as engineers, the information and the knowledge about the injection molding process is very important, and that was the basic idea of having this particular discussion on injection molding. So with this we come to the end of today's lecture, that is on injection molding. This particular lecture has been covered in module number 4, that is processing of plastics, under the course processing of non-metals. So what we have covered today, we have covered the basic process of injection molding. I have drawn a very simple diagram to just represent the working of the injection molding process. We have seen that broadly the stages can be classified into 4, that is, first stage is the clamping, in which the mold cavity closes down or the mold closes down to form the mold cavity. Second stage is the injection, in which the raw material which is available in the form of powder or pellet is pushed by the cylinder, piston and cylinder type of arrangement into the mold cavity. So the raw material, it is heated, it is melted, and it is pushed through the nozzle into the mold cavity. And once the plastic has filled the mold cavity, it is allowed to cool there. Once the cooling process has been completed, the two mold halves which have clamped together in the very first stage of clamping now open. The final product which has cooled is attached to the movable half of the mold. The movable half of the mold moves away, and finally there are ejector pins which eject the final product out of the mold cavity, or it pushes it away from the moved ejector pins pushes the final product away from the movable half of the mold. So basically there are 4 stages. First one is clamping of the mold, second one is injection of the raw material into the mold cavity, third is the cooling in which the final product cools inside the mold cavity, and finally the ejection where the final product is pushed out from the movable half of the mold with the help of ejector pins. And then we have tried to understand that what are the important advantages and limitations of the injection molding process, and finally we have seen only few application areas of injection molding, and I have told that there are a large variety of products which are made by the injection molding process. So with this we finish our discussion on injection molding. In our subsequent lecture we would focus our discussion on thermoforming aspects and some of the other processes which can be used for processing of plastics. Thank you.